Hello, Kirtana, am I audible? Kirtana, am I audible or not?
Yes,
Okay, so yes, in the last class, we did some problems. The topic was bio-Savart law. Okay, so I'm giving you one problem, one more problem. Similar problem. So, we're given find a long sheet. Basically, you have a rectangular infinite sheet where the length has basically this length is infinite, infinity reaching to infinity. Bottom side also it is going to infinity. So you are given infinitely long sheet with definite width. In this same plane, in this particular given plane, okay. So basically, this is a sheet. From this sheet, you have a point at some distance. This is a point B. Okay. So what happens is, in this problem, what is given is total current through the sheet is going as I. What I am saying about this, what does this mean? You know that current flows through the charges, right? So if I say this is a whole of a wire, okay, this is whole of a wire, this is the whole of a wire, and total current I is flowing. You know the current is flowing due to the all the charges inside, right? So what you have to assume that if you take out at any small portion, the current I dash will be same. Okay, the current density you can call that as the same. So here also, if I ask you about the sheet, the total current flowing is I. Maybe you can call this I. The total current of the sheet. Mean to say for if you take the whole of width of the total current flowing is I, so and have a constant current density. Mean to say if you take this small portion and if you take this small portion having same density, basically area, the current will be same. It doesn't matter which point you are looking at. So you have to calculate the magnetic field, uh, calculate magnetic field at point P. Okay, given that uh, current is flowing as shown figure, current is distributed uniformly. Makes sense. So this is the problem. And you can say the width is given as d. The width of this is given as d. This width is given as d. I hope you can try this problem. Kirtana, you are given the sheet, the width is d, current is flowing I. You have to calculate current magnetic field at this point. Please get me the solution first. Direction you know because current is going upside. Okay, just apply the thumb rule. As per the thumb rule, your thumb will be pointing upside. Your all the fingers will be pointing this side. So this face of your this palm will be pointing inside the plate. Always use right hand for this. Okay. So when you do this, I can say that the direction is nothing but inside the plate. You have to get me the value first at this particular point. Did you understand the problem, Ketana? Yeah, Ketana, any query you have with regards to the problem? Ketana, please let me know first.
No,
Any? No need, right? Okay, so you can start solving the problem. The time allotted for this is 3 minutes. The problem is still the same, just quite little bit more exaggerated. 3 minutes I have given. Solve it fast. Get me the solution. Okay.
sir, is it u naught I by 2 pi into 1 by r plus 1 by r plus t?
Okay, fine. We'll solve it. I don't have solution for this one, so I'll just solve it and we'll see if the answer matches. So if you see carefully, I'm saying the density is same, right? So what I'm going to say is, okay, I have made it as a sheet, so I can say what's the current passing through this particular portion. Right? This is what my task is. So what I'm going to do is, I know what I'm going to do is, I will go and take some random portion, maybe from here. I'm going to go at this point and I'll be taking some random portion. I mean to say, I'm going to take very random strip. So what if I know if I get to know what is the current passing through this strip, I will able to calculate magnetic field at this point. Okay, Kirtana, first of all, let me know which formula you are going to use for a magnetic field.
u naught I by 4 pi r into sin theta 1 plus sin theta.
Was- Yeah, okay. Okay. Yeah, so I was saying, assume that, yeah, assume that I have taken some strip, okay? This reason. I know this is acting as a wire. So which formula I should use so to calculate magnetic field due to this wire, okay? This is strip actually, because I'm taking the whole strip, right? So which formula I should use?
u naught I by 4 pi into dl sin theta.
Just think of it. What kind of configuration it is? Do I really need to use the complete formula mu naught by 4 pi I times of basically whatever the current I dash is there, right? Okay, this is I naught, the main current. I'm calling this is I red. Do I really need to use the complete formula or some optimization I know about this? What do you think, Yatman? The main task is identifying the formula. Okay, if you see carefully, this is an infinite sheet. It means to say either you go this way, either you go this way. This will going to be 90 degrees. It means when the sheet or length is infinite, I'm not supposed to use this. I'll be using
u
4
naught I
pi
by 2 pi.
and 1 and when you put so it becomes 2. Sorry, it should be r also. That should be r. So 2 pi r equal to this is what formula I'm supposed to use. It makes sense. So I said the current flowing due to this portion is I at this point. So this is the formula I have. What my task is to do. Now you understood the assignment, right? It's a very simple. I am going to integrate. Okay. If I am going to integrate, I will be integrating from 0 to full value of b. And here, because I had to take the complete portion, right? So this is the formula. So this 0 to b. And if you see carefully, to mu naught I, okay, and divided by 2 pi r. So what is the distance? If you see, if I'm saying this is x distance, if I'm saying this is x distance, so what is the total distance? R plus x. This becomes r plus x. Okay. Now, although this I is also a variable, we don't know about this. So what I have to do, I need to represent this I in the form of dx. If you see carefully, my I, this current density, if I talk about the current density, what is it? Total current divided by the area. So because I told you it's a sheet, okay, assume this might be the area, right? So if I'm going to take any small portion, this is still be the same. So assume this is a length, this small is a width. So you can say that previous side length, this is a width. So L dx. It is going to be same for I naught divided by L into the complete width, that is d. So you can simply say I becomes dx divided by d, okay, the complete multiplied by the I. So go and keep it as it is. So if you go and keep the formula mu naught total current I naught dx divided by d. Okay, this was the basically width. So I'll remove this. I will keep it as w so that it won't be a confusing a lot. Okay, although you can say that more the area you are going to cover, more that you are going to get, but so I is directly proportional to what I can say x. So I will be equals to I naught times of dx divided by w, the width. Okay. So yeah, when you substitute the formula instead of I, you have to keep this I naught dx divided by w x plus r. Makes sense. Now, if you see carefully, I will try to keep all the constant outside. Here it is 2 pi. Here also it was 2 pi. So this becomes b is equals to mu naught by 2 pi w. I naught as well, integrating dx by x plus r. From where to where I'm going? I'm taking x value from 0 to w itself, right? So we went up as 2 pi w I as it is log of x plus r, where x is a variable and r is a constant. So this becomes 0 to w. So yes, you just have to keep the formula. Times of what it is. Yeah, just put the value log of w plus r divided by minus log of r. So this whole thing becomes mu naught I divided by, sorry, it should be mu naught I naught, basically the total current divided by 2 pi w of basically the width log of w plus r divided by uh, w plus, if you divide it, you will be getting 1 plus w by. This is what the formula is. Is it clear? Is it clear, Kirtana? Any queries? So look, always take the bigger picture. Okay, the solution which you give does not include all these parts. So this is the formula. We have the right so far. If you have any queries and doubt, please come up with a query. I'll let you know. Please, Kirtana, just go through the solution and let me know if you have any doubt. Kirtana, please let me know. If you're noting it down, if you're understanding it, whatever you're doing, please let me
I'm seeing it.
know. Yeah, okay. So just go through this once.
Understood.
So let's go and look at the new option. Okay? Another problem which will let you know a derivation, basically, which will give you a formula for the magnetic field due to a circle, which we'll derive it in the future by using different method. Okay? So, so assume that I'm giving you a polynomial, no, polygon. What is a polygon? Uh, n-sided polygon. I'm giving you given n-sided polygon, n-sided polygon with equal sides, 15, with equal sides, okay, of length L. This L, okay. Should I give each side as L itself or something else? Assume that I'm not giving you the length of each side. Let's remove it with equal sides. Just assume it to be the equal side. Also, the sum of all sides is equals to is L. Okay, this thing is given to you. And how many sides are given? N sides. We are not given 2, 3, 4, 5, and something. Calculate magnetic field at center. at set. So basically, you have to generate a formula in which if I'm going to keep any kind of what I can say, any value of n, I should be getting the answer. I'll just make all of them as a red. So yes, Kirtana, if you understood the problem, please let me know. The basically, if you understood the question. So here, what I'm saying is, you are given n-sided. I'll just give you some examples. Assume this is like it's not a polygon, right? So the minimum polygon which I can have is three-sided. But assume the shape and size is same. I have been made equal sided. So assume this is a polygon. I have this is three-sided polygon. So in this case, I need to calculate what is the formula. I have to generate a formula in which if I'm going to put the value of n, I should get the value directly, field directly. If the n can be here, this is the case of n is equals to 3. N can be 4 also, right? If it is a 4, it will become square itself like this. If it's a, what I can say, yeah, something like this. If it's a five-sided, so it will become a pentagon, something like this. Things I have to take care about. Okay, so these kind of shape it will become, but so you have to figure out what is the value of magnetic field at the center. Okay. In formal, you can say you are given a field such that this one. I'm not making the rest of part because we don't know how many sides are there. Okay? And this is the center field. So you have to calculate magnetic field at this point. And current is basically flowing in a loop. What is that? Current I itself. So if you understood the problem, please try to solve. Please start solving the problem. Okay? If you understood. In this case, if whatever the formula we are going to get, because you know what is a circle. So circle is basically a polygon having infinite sides. Okay. So in this formula, whatever the formula we are going to derive, if we take n is equals to infinity or something, we will get the magnetic field due to circle. Okay. So yeah, we'll be covering all closed shapes by this having a symmetrical sides. Kirtan, if you understood the problem, please start solving it.
Yes, sir. Sir, can you explain?
All right. So look, Kirtana, assume that what is the complete angle? Can I say the complete angle is nothing but 360 degrees?
Yes, sir.
So let's go with the solution first. So if you see carefully, I what I can do is I will try to look at how what is the angle subtended by each of the sides. So if you see carefully, I can say this is theta, right? But if you see carefully, each of the side will be having the same angle, right? Because of the symmetry. Can I say that?
Yes, sir.
Okay. So if each of the sides has this theta itself, can I say that how many times of this theta I am going to get? Can I say one times of theta, another times of theta, another times of theta? How many times I can get number of side, right? So total angle is how much?
And
N
and
times of theta. And what is the total angle? Complete, that is 2 pi. So can I say each of the angle, here it is given as 2 pi by n. Can I say this?
yes,
Okay. If each angle is given n pi, now can I do one thing? Just think of it. Look, this is a triangle, right? This is a side, you can see. I'll just make it better. The common is follow this. Okay, so here now what I'm doing is I had this kind of shape, right? What I'm doing is, if you see carefully, due to the symmetry, all the triangles, all the side triangles which I'm going to get have same kind of shape, right? If I take this, okay, if I from here, if I rotate it like this, it also is similar to this, right? And it will similar to all of them. So can I wait? If I'm able to solve for this, I'm able to solve for everyone.
yes, sir.
So here the angle is given as theta, right? Let's do one thing, bisect it. The moment you bisect it, what we are going to get? Can I say now, whatever the angle you got theta, this part is nothing but theta by 2, this is nothing but theta by 2.
Yes,
You know the current flowing is Im. Can you calculate what is the magnetic field at this point? P. So this is nothing but dV because each part is very small. So okay, let's call this as B itself. B due to first side. Okay, we have total n sides. So this is first side, second side, third side. Okay? So B1, what is the B1? That is nothing but mu naught I divided by 4 pi divided by distance. What is the distance? Okay, we don't know this distance right now, so let's keep it as r. Okay. What about sine theta 1 and theta 2? If here it is sine theta 1, here it is sine theta 2. If you see carefully, I have both as same, right? Theta 1, theta 2. Can I say this thing as b1 times of mu naught I divided by 4 pi r? And what is this part? This is nothing but 2 times of sine. What is the value of theta? That is nothing but theta divided by 2. So it will become theta by 2. This is theta, theta. Is it clear, clear till now?
yes, sir.
Now, if you see, can you solve it further? Can you think of it? What we should do next? Just think of it once. Look, Kitna. I'll explain it once. Can I say that whatever the B I have got, this is due to the one side, this is due to the second. This is similar to the triangle piece, right? I have assumed that polygon have n side and is supposed to create three side. It means if I can calculate magnetic field due to this one at the center, the same will be due to this one, same will be due to this one. So assume due to this one is B. Can I say the total is nothing but 3 times of B?
Yes,
So now can I say that my B net is nothing but n times of B1?
yes,
Can I
sir.
say this? Okay. But if you see, this part is still incomplete. Why it is an incomplete? Because there's a R. I don't know what is that R. So I have to resolve. Let's do this. You know that I have given you one more thing. The sum of all side is nothing but L. Can I say that? Assume this length is given as A itself. Okay? So can I say that n times of A is equals to L and A will come out as L by n? Can I say this?
Yes,
I needed to calculate R. Now can we calculate the value of r? Yes, we can, because we know this is r. We know this length is this small length is a by 2, right? This is a by 2. So can I say that this r tan of theta by 2, because this angle is theta by 2, right? This is theta by 2. Tan of theta by 2 is nothing but perpendicular to base. Who is the perpendicular? A by 2. Who is the base? R. So can I say that this r is nothing but a, is it what? Yes, it is. A by 2 times of tan theta by. Can I say this? And also we have got the value of a also. What is that a? This value. So let's keep all these calculations aside. So from here you can see it. Now this r comes out as what is value of this value? Keep it over here. L by 2 times of tan theta by 2 and multiplied with n. Okay, this is the value of r. Now again come back. B net is equals to n times of what is b1? B1 is equals to this whole thing, right? So keep the formula over here. Mu naught I divided by 4 by r. 2 times. What is the value of r? Let's keep the value of r. So r is this value, right? So let's look at this. If I remove it, can I put the formula? Yes. L divided by 2. Whatever in the denominator, it will definitely go upside. So it will be 2 times of tan of theta by 2 multiplied with this in and added. This is complete. I have kept it. What is the rest part? This part is this. Was it the rest part? Why 2 over yes. So it will become 2 times of sine theta by 2. This is it. Any doubts so far?
No, sir.
No doubt, right? Okay. Now, if you see carefully, can I do one thing? B net is equals to this is n, this is n, it becomes n square. What is the rest part? This is 4, this is 2 into 2 becomes 4, so cancel out. You can actually go and cancel that out. So this will cancel that out. Mu naught I divided by pi times of L. Okay. Uh, tan times of theta. What is theta? 2 pi by n. So when you are going to keep this 2 pi by n and already it is this, so it will become pi by n. So pi by n. Here also this will become sine times of pi by n. Clear?
Yes, sir.
Any doubt?
No, sir.
No doubt, right? So this is the formula we have got. I hope this thing is very clear to you.
Yes, sir.
Okay. Any doubt? No doubt, right? Now I told you that by keeping the value of n, we can easily calculate the magnetic field due to a polygon of any side. The thing is, the polygon should be regular. Regular mean to say, if I'm saying n is equals to 4, mean to say four-sided polygon. It should not be the case that polygon is looking like this. Okay, it should be symmetric. It should be completely symmetric. Okay, it should not be like this. We are not talking about these kind of polygons. We are talking about regular polygons having perfect symmetry. Okay, so that is the thing. Now I told you if my n goes to infinity, can I say if my n goes to infinity, the polygon becomes circle? Is it the case?
Yes, sir.
Okay. So if I take the whole equation come from here, but if you see carefully, I know one thing. This if I do pi by n, this will become zero because n is infinite. If I do pi by n, for both of the case, it will become one. It will become one. But what about this thing? How I'm supposed to call? Because if I'm going to keep n is equals to infinity, the whole equation will go infinity. Should I do it like that? Should I do like that? The idea is no, because whatever you are doing right now is not different. Because what when you keep pi by is equal this as zero, what happens is directly as zero because it's not exact zero. It is you're dividing something by a very big value. It is approaching towards zero. When this thing is approaching towards zero, you know one concept that if, okay, for any sine theta, tan theta, if theta is less than equals to 10 degree or very small, what you can say that the sine theta is equals to tan theta is equals to theta value in radian. Theta in radian. This is in the radian. Okay? You have to keep the value of theta in radian. Don't do like if it is sine 180 degree, sine 180 degree. Okay? Don't put 180 over because it is you have to keep value as a radian. Okay? That's why I'm writing for this. So if you see carefully, a pi by n is very small, approaching to zero. So due to this, we can say that sine pi by n, tan of pi by n. And if you see carefully, the angle which we are using, it's already a radian. So you can directly give it this. It's clear now? If you go and substitute the value, let's take it and paste it. Can I can remove it from you. I can remove it from you. Okay, it will become square, right? And if it becomes square, you can see n square, this n square get cancelled out. What you are left with mu naught I, and okay, this is pi, this is 1 pi, it will get cancelled out 1 pi. So mu naught I phi square divided by pi times of L. What you are left with mu naught I and this pi divided by L. Is it clear now?
Yes, sir.
Clear. Also, I told you that this L is basically the sum of all sides. What is sum of all sides? Can I say the parameter in circle? We say the sum of all side, basically small side, small side, small side. If you consider that, can I say this is nothing but this L itself? The whole thing is nothing but the L itself.
Yes,
So this L is nothing but you can say if R is radius of a circle, then you can say that L is equals to 2 pi r, right? Can I say that? Then your B net becomes mu naught I by pi by 2 pi r from pi by cancel. What is the formula you are getting? Mu naught I by 2r. Is it clear? This is important because from just because of the circle, I'm assuming r is the radius, so I took a variable extra. Okay. Is it clear?
yes, sir.
Any kind of doubt you have?
No, sir.
So look, we have studied some formulas so far. The Biot-Savart law, I am not discussing about two formulas from there. Another formula was magnetic field due to a wire. What is that? B is equals to basically dB, whatever you want to say. 4 by current itself. Okay. So divided by R times of sine of theta 1 plus theta 2. Now, depending upon what kind of condition you are, if it is infinite, you can keep 90. Okay, if it is semi-infinite, you can keep 90 and theta. If it is like one side 90 and other side 0, you can keep like whatever the condition is, you can do it. Okay. So from here, a special case was there for an infinite sheet. The formula becomes mu naught I by 2 pi r, right? In this case, the above is if it is for n-sided, you can say whatever, but the formula becomes this for a circle. Is it clear?
Yes, sir.
Okay. So that's for the. mm, I'll see if I have one more problem because that's all for the today's discussion from my side. Kirtana, let's go. I think let's not discuss anything further today's. Let's not start a new topic, okay? Because we just have left 10 minutes and we can't cover a new topic completely. Okay? So I'll start a new topic in the next class itself. We have done two major problems in this session, and these two problems, if you see, uh, have a lot of concepts, lot of power solving concepts associated with them. So I will suggest you to do one thing. Whatever we have done in this chapter so far, go through, revise each line one by one. Take your NCRT, read line by line. Okay, solve the whatever the problems in the last class. I think I gave you three problems. Today we did two big problems. Okay, if you solve all these things, you will get a brief idea. In the next class, I'll be starting magnetic field due to current carrying loop. Although you can do that also, magnetic field due to current carrying loop. Okay, if there's a loop like this, we have to solve in the next class. We'll be solving just like we did in case of electrostatic. Right, we had a loop. So I said this is the center of the loop. From here, if you are going at some distance r, what is the magnetic field at this point p? Okay, this is the discussion we are going to have in the next class. Here I can just give you a brief that if you take any point, because the current is going like I, okay, this current is going I. So you know this is kind of thing. Due to this one, if you take small portion, due to this one, okay, let's take it from the top because it will be easier for us. It is going this way. So due to this one, the current, the magnetic field from here to here is in this way. What's the direction of it? It is this perpendicular. Okay? Because current is going at this point, because if the current is going inside the plane, okay, this is R, so you know this should be perpendicular. This is how. Now you know with for this point, if you will be talking about this point, because current is going, because it's a loop, right? It's a loop. Maybe it's a circle. So if you are looking it from the side, what you are going to see is this is a circle again. Current is flowing I. So if you're looking at the side, maybe there's a person. We are actually looking from this side. Okay? If you are looking from this side, what happens is we are seeing the current going inside here, because for us this will be the plane. Okay, this is the page or something. And if you look at the bottom side, it is coming. So here, this you will see the current is coming, and here you will say the current is going inside. Did you understood this thing?
Yes.
So what happens is due to this part, because the current is coming out, due to this part, the magnetic field will be like this here. Okay, perpendicular to this, and this is also perpendicular to this. So again, you know the thing we have done in the last class is that if this is the theta, we will take out some relation and we'll make some. We'll say this is also theta. If we put some angle over here, maybe this like this, so you will say this is also theta. This is theta. This is magnetic field because the length and everything is same. Magnitude will be same. Then you will say this is b of cos theta. Here it is b of sine theta. What is it? Yeah, b of sine theta. So at the end of the day, what you need to do is just calculate the b sine theta because cos theta get cancelled out. Integrate the b sine theta for complete circle. You will get the answer. Okay. This is what the thing we will be discussing in the next class. Any doubt? Kirtana, any doubt? In
No, sir.
it? No, right? Okay. So that's all for the today's session, Kirtana. Um, you can try that. You can give a try to the thing which I have just discussed right now. Okay.
Okay, sir.
You can actually give it a try because it's just a derivation and we have discussed how to do these kind of derivation. Okay. You just need to keep uh, you have to take care of the angles. So that's all for today's session. Kirtana. I'll end this session by this. Goodbye.